Ianthasaurus, the first stage in the rise of cows. Hi, it's me, and welcome to Paleologic. Today we are discussing the first cows. Okay, technically not cows, but an animal that was instrumental in the rise of cows. And so I thought we should talk about it. This is Ianthasaurus. Ianthasaurus was a small sail-backed synapsid from Late Carboniferous North America. More specifically, it's from the upper part of the Pennsylvanian, which dates this animal to around 320 million years ago. It also means that it lived just before the great mass extinction at the end of the Paleozoic, though some of its relatives did survive into the Permian and lived well beyond this point in time. The remains of Ianthasaurus are known from 3 different states across the midwestern and eastern side of the U.S., including Texas, Oklahoma, and Illinois. The discovery of this animal was actually quite recent, having been found in 2005 and then officially described in 2013. It was the first new genus of Adaphasaurid to be discovered in almost 70 years, and one of only a handful of species in the entire family to ever be found. In fact, there aren't even that many fossil remains of Ianthosaurs because all that we have consists of 2 partial skulls and a few other random bones. Not much material to work with, but enough to get the job done. Ianthasaurus belonged to a group called Adaphosauridae, which were a lineage of early synapsids that were relatively small proto-mammals that lived throughout much of the Carboniferous and Permian periods. The name Adaphosaurus means good-standing lizard, and in reference to the fact that these animals were small and often found in an upright position when fossilized. Although they are considered a very basal group of synapsids, meaning that they are close to the root of the mammalian family tree, Adaphosaurids are actually somewhat removed from our direct ancestors. They branched off early in synapsid evolution, perhaps after the divergence of the mammal-like reptiles or therapsids. This is why we find them as more primitive and less derived compared to other later synapsids. However, they still shared many key features with their more famous cousins like large temporal fenestrae or holes on the sides of their skull. These large openings allowed for powerful jaw muscles to develop and would be a feature that we see shared between Adaphosaurids and the group that leads to modern mammals. Adaphosauridae is also an interesting example of a group that exhibits mosaic evolution. That is where different parts of the skeleton show different degrees of morphological advancement. For instance, the skull of Adaphosaurids can be fairly primitive depending on the region being looked at, but their teeth and jaws are actually quite advanced for their time period, showing clear mammalian features. Interestingly, it seems that this group may have actually been among the first vertebrates to exhibit heterodonty, or the possession of different types of teeth within the same mouth. For example, the front teeth of Adaphosaurids were likely used for catching insects, while the teeth towards the back of the mouth were better adapted for crushing. The appearance of heterodonty in early synapsids is pretty significant, because it has long been thought that the development of different types of teeth is one of the major factors that correlates with the transition from a primarily insect-based diet to one that includes plants. Obviously, specialized teeth for biting, tearing, and grinding would be essential for dealing with vegetation. So, if the presence of heterodonty is one of the earliest steps in the evolutionary path that lead to the emergence of the first dedicated terrestrial herbivores, then it would make sense that these early synapsids were closely tied to the rise of plant eating. And the evidence does seem to support this hypothesis. And that brings us to Ianthasaurus, which is a genus that falls within the family Adaphosauridae. Ianthasaurus was probably around 1 meter long and weighed less than 3 kilograms. Like other Adaphosaurids, it had a slender body with a long tail and a large sail-like extension of the neural spines along its back. This sail wasn't unique to synapsids, and other unrelated animals such as sauropods would evolve similar structures as well. In fact, these sails are now thought to have been an example of convergent evolution. Their function is still up for debate, but they are likely used for display, thermoregulation, or both. Interestingly, the diet of Ianthasaurus changed as it grew. This is a phenomenon known as ontogenetic dietary shift and is actually quite common in the animal kingdom. As juvenile individuals, they seem to have been active insectivores, perhaps feeding on smaller arthropods which were abundant in the lush Carboniferous forests. They likely used their sharp teeth to snatch up insects and other invertebrates. But as they got older, the diet of Ianthasaurus broadened to include plants. This change in diet may have played a role in the evolution of those specialized teeth, which could have eventually become differentiated into the various types of teeth that we see in modern mammals. After all, cow teeth are very different from each other and serve very different functions. The incisors in the front are used for clipping vegetation, while the sharper teeth behind them are better for tearing and grinding. Now, cows do not directly descend from any of the synapsids. Instead, synapsids represent an early branch on the mammalian family tree, a sort of deep cousin. But as such, they still tell us a lot about the origin and early evolution of mammals. And what makes Ianthasaurus particularly interesting is that it appears to have been the first species to exhibit a clear dietary shift from insects to plants. However, this doesn't mean that no other animals didn't eat plants before this point. After all, the earliest dinosaurs were likely herbivorous. But what makes Ianthasaurus special is that it's the first tetrapod, or four-footed vertebrate that shows clear evidence of this dietary transition. Even today, there are very few land vertebrates that are solely dependent on eating insects. Most animals need to supplement their diet with other sources of nutrition, especially calcium. And so Ianthasaurus, with its more varied diet, would have been better suited to life on land, and less reliant on the nutrient-rich water sources that were likely important for earlier vertebrates. This dietary flexibility would have been extremely advantageous in the late Paleozoic as environmental conditions changed. In fact, Ianthasaurus may have even benefited from the mass extinction at the end of the Carboniferous because it opened up new ecological opportunities. Regardless, this dietary transition would have been an important step in the evolution of mammals because it led to the development of adaptations that allowed for larger body sizes. One of the biggest problems with being an early tetrapod was that there was a size limit imposed on how big you could get. It's difficult to grow beyond a certain size while relying on aquatic habitats for nutrients. But once animals started supplementing their diet with terrestrial plants, there was no reason why they couldn't get big. Obviously, getting bigger also came with its own set of challenges, such as the need for strong limbs to support the added weight and changes in posture. But these issues were eventually solved and ultimately led to the gigantic forms that we see in later mammals. Cows, of course, being an extreme example of this. So, in summary, Ianthasaurus was a small sail-backed synapsid that lived during the late Carboniferous of North America. It is notable for being one of the earliest vertebrates to exhibit an insect-to-plant dietary shift, which would eventually lead to the rise of the first true terrestrial herbivores. Its evolutionary legacy is not direct, but instead represents an early step in the history of mammals. But what do you think? Is there anything surprising about early mammals? Let me know in the comments below, and thank you all so much for watching. If you enjoyed this video, please leave a like and consider supporting the channel. Thank you all so much for watching, and I will see you next time.